is Lezhnina, and today I'm gonna present you my project for material science class. My project is about compliant mechanisms and structures. So, first of all, mechanism is a mechanical device used to transfer or transform motion, force, or energy. And compliant mechanism is flexible mechanism that achieves force and motion transmission through elastic body deformation. It gains some or all of its motion from the relative flexibility of its members rather than from rigid body joints. On this slide, you can see some of the examples of the compliant mechanism. And for example, here there is a compliant joint which provides the structure with flexibility. Another important aspect is the materials which are used for these structures, and the most commonly used materials are mono and polycrystalline silicone, silicon nitride, nickel, copper, gold, and epoxy resins, and others. There are many advantages of the compliant structures due to these attractive properties, and the most important of them is precise motion, as you can see on this video. A very important aspect of compliant mechanism is the assurance of precise motions. The tests have shown that those structures worked very well and the repeated motion was always accurate and precise. Here there are more advantages. Low cost. A compliant mechanism can usually be fabricated into a single structure, which is a dramatic simplification in the number of required parts. Because they have fewer parts and simple manufacturing process, compliant mechanism can be very inexpensive to manufacture. The reduction in parts count may simplify manufacturing and reduce both the manufacturing and assembling time and cost. Compliant mechanisms can be simple to manufacture because they lend themselves well to various manufacturing process. For example, they can be manufactured using like many methods as machining, stamping, laser cutting, water jet cutting, and 3D printing. Another aspect is proportions. Compliant mechanism is the ease in which they are miniaturized. Simple microstructures, actuators, and sensors are seen widely usage in other microelectromechanical systems. However, there are some disadvantages of these compliant structures. First one is limited motion. Due to the nature of flexural joints, no purely compliant mechanism can achieve continuous motion such as found in normal joint. And another one is the force applied by a mechanism are limited to the loads the structure elements can withstand without failure. Because of these attractive properties, compliant mechanisms are specifically well suited for applications in the fields of micro and nano engineering, aerospace, semiconductor equipment, microelectromechanical systems, smart structures, metamaterials, and surgical robotics. On the last slide, you can see my 3D model is just the example of compliant structure. It's just one example. Actually, there are many of them. I used Sharp 3D to create this 3D model. Thank you so much. 3D model that I've created in Sharp 3D, and I tried to show you the compliant joints, which are here, here, and here. They provide this model with flexibility. This is just a model. For example, it can be printed using 3D printer. However, the material is important for the flexibility of this structure.